Hello, Maurieo. Slopes and gradients. A look at slopes and gradients as they apply in an engineering and surveying sense. The grade, also called a slope, incline, gradient, pitch or rise of a physical feature, landform or constructed line, refers to the inclination of that surface to the horizontal. That means that they can be both positive and negative. Positive being an elevation, negative being a depression. Often slope is calculated as a ratio of rise to run, or as a fraction, rise over run, in which run is the horizontal distance and rise is the vertical distance. You might measure grade or slope of existing features such as a canyon and hillsides, stream and riverbanks and beds, or one might easily specify grades for new construction such as roads, landscape and garden grading, roof pitches, railways, aqueducts, pedestrian handicapped bicycle circulation routes, pipes, stormwaters and what have you. All of the above information has been supplied to us or come from Wikipedia, as has the diagram below. Thanks to them for their help. D in the diagram here equals your run. Note that's a horizontal distance. Horizontal, not the slope distance. L is what we're referring to in the run, and the rise, of course, is the vertical distance, the difference in height, which of course is at perpendicular to or right angles to the slope to the horizontal distance D. The angle of inclination is shown there. That's the angle with the horizontal. It can be above an angle of elevation or below an angle of depression. So moving on. Alright, there are several ways that we can express a grade. Note they are positive or negative, elevation or depression. One of the main ways is the ratio. A rise of 1 metre vertical over 20 metres horizontal, 1 in 20 or 1 to 20. They're expressed either way depending on how you roll. Generally the ratio starts with a 1 and they are dimensionless, so it could be, while it could be 1 metre in 20 metres, it could equally be 1 millimetre in 20 millimetres or 1 kilometre in 20 kilometres. The ratio is dimensionless. Now we can also express these grades as a percentage, and we do that by multiplying 100% times the rise over the run. So 1 in 20 is equal to 100 times 1 over 20%, or 5%. And there are various tables and little graphs and things throughout the internet, and I've shown a couple here that show you the relationship between these two things, the ratio, the percentage and the angle, the third one that we're going to deal with in a moment. Normally for percentages, just kept for the flatter grades, possibly with an upper limit of say 16.67%, which is around about 30%. Beyond that they start to come a little bit ridiculous, because if you look you can see that the 45 degree angle is a 1 in 1 grade, and that obviously gives you 100%. So then we start to get grades up to 500% and 1000%, and they come a little bit meaningless and difficult to understand or visualize. So just generally we stick with the percentages for the flatter grades. The angle is an angle of inclination to the horizontal. Pretty easy, because it's just the tangent of obviously rise over run is the ratio, is the tangent of the angle. So we just go tan to the negative 1 over 20 in the case of a gradient of 1 in 20, or 5%, and that will give us 2 degrees 51 minutes 45 seconds if that's how you want to express it, or as 2 degrees 2.8624 degrees. So there are other ways of actually expressing these as well, but they're the three main ones that you will possibly encounter as an engineer or as a surveyor. There are some ways of expressing these that are quite specific to particular occupations, and I'm sure that you will pick those up fairly quickly if you are put into that situation. Now here we're going to actually try and calculate a grade from a contour plan. The contour plan I've chosen here is it's sort of trying to show things in a three-dimensional manner. So I've chosen that in the hope that it'll sort of help to you to visualize what's going on. So in this case here we've got A and B, and they're on A is on the 20 meter contour and B is on the 40 meter contour, and the horizontal distance between them is 361.56 meters. 361.56 meters. Note the contour interval of 5 meters. It's important that you work that out and get it right, because obviously if you have miss a contour or misinterpret the contour interval, that's going to mean that the calculated gradient will be incorrect. So calculate the gradient of AB. A as a ratio. So the rise is 40 minus 20, which equals 20. These are all in meters, so and the ratio is dimensionless, as I've said earlier, and the run is 361.56. So here we are. We have the gradient must be 20 to 361.56 because it rises 20 meters. Now, but we always like to have the 1 in the front, so just divide through by the 20, and sort of 20 divided by 20 is 1, and 361.56 over 20 gives us a gradient of 1 to 18.0780. I've just kept that to 4 decimal places because, well, quite frankly, my calculator was at 4 decimal places because I'm using it for degrees, as you'll see, degrees, minutes and seconds, as you'll see below. But generally 2 decimal places possibly enough. It just depends on how accurate you want to be. So how do we do that same gradient as a percentage? Well, just use the little formula I said. Gradient equals 100% times rise 20 over run 361.56, and that gives us a percentage of plus 5.5316. I've said plus because we're going from A to B, we're rising up. Obviously the gradient from B to A would be negative 5.5316, and it would be an angle of depression looking down to B if we did it as an angle, or an angle of elevation if we're going from A to B. Now let's calculate the ratio, the gradient, as I said, or the grade, as an angle, and the gradient equals, in this case, plus tan to the negative 1 of 20 over 361.56, which is plus 3 degrees 09 minutes 58, or 3.1661 degrees. So there you have it, the inside information on grades and slopes.